Welcome back. We are going to take the next class, that is class number 38 in the subject Introduction to Mechanical Engineering. Myself Dr. Sachindra Kumar Rao, Department of Mechanical Engineering, C.V. Raman Global University, Bhubaneswar. So in this class, we will discuss second law of thermodynamics and its formal statements. In the last class, we have discussed the first law of thermodynamics for closed system, for open system, and we have also seen the enthalpy, internal energy. In this class, we will see the two formal statement of second law of thermodynamics along with the perpetual motion kind 2. So, in the first law of thermodynamics, there are some deficiency. That means it tells about the quantity. It will never tell about the quality. It means we can explain with three examples. That means let's say this is a hot cup of tea. If you leave it in the open air, the heat will go to the surrounding air. And if you try to back this amount of heat to the tea, then whether it is possible or not, or it will get the same amount of energy or not, that is not answered in the first law of thermodynamics. So similarly, another example is there is electrical wire where by supplying electric, we are able to produce some amount of heat. Whether the reverse is possible or not, means if you are supplying the same amount of heat, whether the same current will get or not, that also not answered in the first law of thermodynamics. Similar manner, if one more example, using a pedal wheel, if you lowering a weight, the amount of heat produced, if you reverse it, that means if you supply the same amount of heat to this pedal wheel, whether the weight lowering that will go up or not, that also not given by the answer is not given in the first law of thermodynamics. So the answers about the quality, the direction of heat flow or the direction of energy, that is not answered in the first law, that is answered by the second law of thermodynamics. There are two formal statements in the first law of in the second law of thermodynamics. One is for engine, another for heat pump or refrigerator. So in engine, there is a heat source from where we are taking some amount of heat, and it is releasing to the releasing to a sink, and we are getting a net output. So the statement says that without releasing some amount of work, some amount of heat, we cannot produce a work. That means the Q is not equal to W. So from here the statement comes that it is impossible to construct impossible for a heat engine to produce net work in a complete cycle if it exchanges heat only with one body, with a body at a single fixed temperature. That means this is if we take the source, the net amount of heat is sending to the engine that cannot be converted into work. That means 100% of Q cannot convert into 100% of W. That means QH, we cannot say QH not equal to W. That means there is a QH, some amount of heat it will release, and we can get the net amount of work. Sorry, there will be work. That means QH minus QL, it will be W. That means QH not equal to W. That means W is lower than Q. So this is the statement and definition of the second law of thermodynamics based upon Kelvin Planck. So you can see this is not possible. That means if you providing 100 kilowatt of heat, and we will get 100 kilowatt of work, and that is not possible. So it is the explanation of this statement. Now the next statement is Clausius statement. So it is based upon refrigerator or heat pump, where it is trying to explain that the amount of heat required to transform from a hot body, from a cold body to a hot body without any external work or any external effect, it is impossible. That means it must require some amount of work. If you transfer some amount of heat, that means lower temperature to higher temperature, you must require some amount of work to perform. So from here the definition says that it is impossible to construct a device which operating in a cycle will produce no effect other than the transfer of heat from a cooler to hot body. So that means it must require some amount of work to transfer heat from a low temperature to high temperature. So as the two statements looks different, but it can be proved that if any system violating the one statement, definitely it will violate the other statement. So that can be proved here. So let's for that example, for that proof, we can take two system, one is engine, another is refrigerator. So where engine, let's assume the engine violating the first law, engine violating the second law. That means as an engine there must be two reservoir, but as it is violating, so it is operating in a single reservoir. That means net amount of heat, let's assuming, is converting to W, and that W is providing to this refrigerator the W net, which is, we can assume that the amount of heat it is taking QS, that is equal to W, and it is input to the refrigerator. So now the refrigerator is transferring heat and transferring heat from lower temperature to QL by taking the amount of W, that means QH. So now it is getting a total heat, how much? QS plus QL, operating in a single operating the reservoir where the reservoir is TH and where the reservoir TL, means lower temperature. Now it is getting a how much amount of energy, that means the net effect it is transferring QH is the amount of heat it is taking from this heat. That means it is violating the second law of thermodynamics by given the Clausius statement. So that means from here it is proved that if any amount of heat, any machines violating a second law of thermodynamics of one statement, that means it is violating the second law. So if we go to the statement, any device that violates the Kelvin-Planck statement also violates the Clausius statement, and vice versa. So from these two figures you can see. So if the difference you can see QH plus QL minus QH, it will give you the, that means QL transferring to the same amount of heat to this reservoir without any effect, because here it is providing QH and it is getting QH. So if you minus these two statements, QH plus QL minus QH, you will find only QL amount is the same amount of heat transferring the heat transfer. So this is the proof of the Kelvin, the two statement, Kelvin-Planck statement and Clausius statement. So now we have already discussed the perpetual motion kind 1, where we have seen that PMM1, that means the machine which violates the first law of thermodynamics, that machine does not exist, or it is not possible to operate that machine, which already we have discussed. So for more explanation, we will give an example. You can see this is a power plant where there is a boiler, it is heating by externally previously actually, but let's assume this boiler is heated by electricity, and we assume that the part of electricity it is produced can be used to heating this boiler. So once the system will operate, then we take the same current from the same output from the power plant, and we cut the external power cut. So that means theoretically we are not taking any electricity to operate this boiler or pump, we are taking a part of this electricity to run this machine. So that means the energy only out, that means we are getting any all energy, whatever the out, there is no input required. That means this is the violation of first law of thermodynamics. So that's why if any machines which violate the first law of thermodynamics, that must not possible, or it is not feasible, this machine. So it is a violation of first law, that is a machine impossible. So this type of violation of machines available means theoretically available but practically not possible. So there are many patents available in previously, though, who has earned many amount of dollars or $1 million of funds available in literature, but later it was proved that machine is not practically possible. So so coming to the next point, PMM2, that means if it is violating the second law of thermodynamics, then it is known as perpetual motion kind 2. And here, for example, the amount of heat is taken in the boiler, that means it is and producing some amount of work, it is satisfying first law of thermodynamics, but it is not releasing the heat. That means the Kelvin Planck statement, it must release some amount of heat at the sink part. So as it is not releasing, that means it is violating the second law of thermodynamics. So it is not practically possible. So any machine who is violating either law, that means first law or second law, it is known as perpetual machine kind. Based upon it is violating first law or violating second law, so you can say that that is the kind 1 or kind 2. So with this we come to end of this lecture. So we have discussed two statements of thermodynamics. One is first law, another is second law by Kelvin Planck statement, another is Clausius statement. So one is for engine, another is for heat pump or refrigerator. Then we have seen the equivalence of the machine. Equivalence of the machine means if any statement violating, any machine violating the Kelvin Planck statement, then other machine also violating the second statement, that means Clausius statement. So then we have seen the perpetual machine kind 1 and also kind 2, two examples. And the next class we will see, next class we will discuss about the heat pump and refrigerator. Thank you.